This video is on section 3.1. Goes along with homework assignment 31 and 32. You're going to find homework assignment 31 and 32 to be very similar. I'm going to have two assignments, and you may want to watch all of the videos before you start this. I also have a blank assignment sheet in your class notes and one with the key, and there's so much information. I'm going to go ahead and use the one that's marked up as key, and you may want to do the same thing. First thing we're going to do is to talk about polynomial functions. Now, we've already studied these, but we're going to learn some terminology. If you have a function that states f of x, or remember that's y equals some number, that's called a constant function. If you have y equals ax plus b with x to the first power, that's a linear function. F of x equals ax squared, that's a quadratic. F of x equals ax cubed, well, that's a cubic. And if it has ax to the fourth power, well, that's called a quartic. Now, any of these orders, or any that are higher, will just be known as a polynomial function. The ones that we use the most, those with 4 and less, each have their own special name. An exponent of a polynomial function must be a positive integer. Therefore, you'll see we will not use any x, say, to a negative power. We will not have any, say, x raised to the 1/2 power. We will have positive integer exponents. Some characteristics of polynomial functions is that they are continuous, they are smooth wavy lines, there's no jumps, there are no sharp corners, and there are no holes once you graph these things. Looking at 4 examples here and asking the question, which graphs are polynomial functions? If you look at graph A, we would say no, because here is a sharp corner. If you look at B, there is a smooth wavy line, that would be. If you look at C, it looks like a smooth wavy line, but here's a hole, so no, it's not polynomial. If you look at D, here is a complete gap in the problem, so that's not known as a polynomial function. Another thing to think about, and it's at the bottom of this page, a lot of our information will be based on the leading term. The leading term of a polynomial is the term with the highest exponent. And yes, it should be the first term, but sometimes you'll have to rearrange the problem so that it is. Now, we're going to talk about 2 rules here, and I want you to listen carefully. You may have to listen to this several times. The degree of the leading term determines at most the number of zeros the graph will have. Now, degree being exponent of the leading term, so we're talking about the highest exponent in the problem, will determine at most the number of zeros. Now, interchangeably, I'm going to use the word zeros or roots or x-intercepts. Zeros, roots, x-intercepts, or even maybe just solutions. Next, we're going to say the graph will have n minus 1, so the highest exponent minus 1, relative maximum and minimums. Now, for example, if you have the problem y equals 3x to the 5th, it can have up to 5 zeros. Now, it may have less than. Remember those words, at most? It may have less than, but it could have 5 zeros. That's 5 x-intercepts. It can have up to, maybe less, 4 maximum minimum, 1 less than that number. One other thing I want to call your attention to, and it's not in any notes I found in any books, but it goes back to what we already know. Here, when we had y equals mx plus b, if you remember this b, the constant on the end, was a y-intercept. That's still the case in polynomial functions. Now, I think our first note that our thing we'll first go through is actually back to naming these. I've already got them here, so I just want to talk through them with you. We're going to classify as constant, linear, quadratic, cubic, or quartic. All right, number 1, I look for the highest term, and it's negative x to the 4th. Degree 4 tells me it's quartic. Don't get that confused with quadratic. Number 2, the highest leading term is negative 3x squared. The square, the degree 2, tells me that's quadratic. Number 3, the leading term, the highest term, is x to the 4th degree, that's quartic. Number 4, I have an x term, x to the 1st, that's linear. Number 5, x cubed, 3rd degree, cubic. Number 6, x to the 6th. Any degree higher than 4, remember, will be known as a polynomial. Poly means many. Polynomial. 7, x to the 5th, 5, polynomial. 8, negative x cubed, that's cubic. Number 9, x squared, that's quadratic. And number 10, we have no x at all. That would be known as a constant. Now there's much more to this section. I'm going to just stop this and start with a new video.